Hello Physics 10, welcome to a video series that we're going to use to inshallah help you study and slow down the class a bit. Now truthfully speaking, you're here for one of two reasons. The first is to hear me jam out on guitar. Or you're actually here to learn how to properly assess and analyze physics graphs. Now, one key thing to remember is that physics isn't math. Physics uses math to showcase some of the theories and concepts. One of the mathematical applications that we use in physics is slope. And slope, which is otherwise known as the rise over run, can be used to determine various things. One of the things that we do use it for in physics is to help us determine how fast an object is moving. If you have a distance and time graph, the slope of the distance and time graph, or the rise over run, gives you the object's speed. And that's because the speed of an object is determined by its distance over time. And when we take the rise over the run for the distance and time graph, what we're really doing is dividing the distance, or the y coordinate, over the time, the x coordinate. Now, another thing that we can do with the slope formula is help determine the object's acceleration. That is, when it changes its speed over a certain time interval, or over a certain amount of time. In order to get the object's acceleration, we would need a VT graph, either a speed and time graph or a velocity time graph. Just like in the distance time graphs before in the previous example, the slope of a velocity time graph gives us the acceleration. If the line slopes downwards, that means that the acceleration is negative and that the object is likely slowing down. If the VT graph slopes upwards, then, on the contrary, the object is likely speeding up as it is a positive slope or a positive acceleration value. One of the last physical quantities that we can get from graphs is the displacement, or in some cases the distance. Now this requires a VT graph, and unlike the other applications, we're not going to calculate the slope. We're going to calculate what we call the area under the graph. And the area under the graph for a VT, or speed and time graph, or velocity and time graph, will give us the distance or displacement. If we have a velocity time graph, the area under the graph will be a displacement. And if we have a speed and time graph, the area under that graph is going to represent the distance. Now, some graphs are more complicated than others, and that might require us to calculate more than one area under the graph if the graph presents more than one shape. To get a better idea of what we mean, let's take a look at an example.